We now are going to have two more problems that use more of what we've just learned in section 7.4 for those formulas and identities. Number one, a graph of the equation y equals cosine of 2x plus the cosine of x for all solutions between 0 and 2 pi is shown. I'd like you to pause the video and write down what you think the solutions are going to be for the x-intercepts of that graph. And now we need to find the exact values and then 3 decimal place approximations. So I know that my 3 choices to rewrite the cosine of 2x is going to be either with the cosine squared or the sine squared and the cosine squared. And since I have a cosine there, I am going to realize that I'm going to probably need to factor this. So I don't need to mix up my sines and cosines. So I'm going to choose to write this as 2 cosine squared of x minus 1. And then I still have that cosine of x. And now I just want to rewrite this in what would be more graphable form. 2 cosine squared of x plus the cosine of x minus 1. And now, as I've mentioned before, a lot of what we're going to do in Trig in these last few sections, or in Chapter 7 especially, is use what we see as the algebraic structure. So hopefully you can see that this would be similar to 2x squared plus x minus 1. So again, I'd like you to pause the video and go ahead and factor the 2x squared plus x minus 1, or if you can, go straight to the cosine x, and then I want your solution, your 2 factors, to be in terms of cosine. So go ahead and pause the video and factor that. Hopefully you recognize that the factors should be 2 cosine x minus 1 and the cosine of x plus 1. Then we're going to set both of those factors equal to 0. And we're going to solve for the cosine of x. We're ultimately going to be solving for x, but to begin with we need to solve for the cosine of x. So the cosine of x equals 1/2 and the cosine of x equals -1. And so this is where I would refer to my unit circle, simply because that's what I've been using mostly. Where is the cosine of x equal to 1/2? That's going to occur at pi over 3 and at 5 pi over 3. And that makes sense. That's going to be those 2 places. And then I also have where is the cosine of x equal to -1. That's going to be at pi. Then putting these into our calculator for our decimal approximations, for pi over 3 to 3 places, I would get 1.047. For 5 pi over 3, I'm going to get 5.23. Rounding correctly, I would get a 6. And for pi, again rounding correctly, I would get 3.142. Number 2, an isosceles triangle. Area of an isosceles triangle. An isosceles triangle has 2 equal sides of length a, and the angle between them is theta. Express the area A in terms of a and theta. So I'd like you to pause the video to begin with and draw the triangle given that information. This is the only information that they gave us. 2 side lengths, equal side lengths are a, the angle between them is theta. We know that the area of a rectangle, area of a triangle is 1/2 base times height. So my base but my base is that side that I drew it as sitting on. My height, because this is an isosceles triangle, if I draw the altitude, that is going to split my base in half. So now this is my 1/2 base, and it's also going to split my angle in half. I'm going to call this my height because it is. And so now, if I think about my triangle, I have this angle right there is I can look at the sine of theta divided by 2, because I broke that angle in half, is the opposite, 1/2 b, over the hypotenuse, which is a. Now if I solve this for the 1/2 b, because in my formula I have 1/2 b, then I'm going to find that 1/2 b equals a sine of theta over 2. I can do a similar thing to find my h. I can take the cosine of theta over 2, And that's the adjacent side, so the h over a, the hypotenuse. And again, if I solve that for h, I'm going to get that my h equals a times the cosine of theta divided by 2. Now I know that 1/2 b, which I have right there, so my area 1/2 b is a sine of theta over 2, and my h is times a cosine of theta over 2. If I multiply my a's together, I have a squared. And then if I use my half angle formula, I can write this as 1 minus the cosine of theta over 2. And I can write this one as 1 plus the cosine of theta over 2. So remember, we have square roots, so I can multiply what's inside those square roots together. Hopefully you recognize that my numerators are difference of perfect squares. So I have 1 minus cosine squared of theta over 4. Do you recognize that 1 minus the cosine squared of theta is the sine squared of theta over 4? Well, now I can take the square root of the top and the square root of the bottom. When I do that, I have a squared. The square root of sine is, or square root of sine squared is sine, and the square root of that 4 is 2. So I could write it like that. I could also write it as 1/2 a squared sine theta. And now, as the directions said, I wrote my area in terms of a and theta. If you have any questions on either of those examples, again, I look forward to seeing you in class.